Obviously, within the oil and gas industry, there's many different approvals affecting different parts of the industry. I would like to focus on the areas where we have a great need for the seals and bearing systems. As you can see here in the center, the main industry approvals we're focusing on today are the American Petroleum Institute, API, the National Association of Corrosion Engineers, known as NACE, and NORSOK, which is an industry standard which has come about in the last 10 years or so. But what's very interesting is that you can take some of these specifications and now they're being adopted and used as ISO standards. So you can cross-refer some of the main standards like NORSOK M710, which now has an ISO number. If we just focus in for a few minutes now on the NORSOK M710 specification, this originally came about 2001 by the Norwegian petroleum industry, and it's administered, and the Norwegian Technology Centre makes sure that it's kept up to date and that the specifications are followed at all times. When you talk about the effect of different materials being tested to the NORSOK, there's a slight difference when you talk about the elastomeric type seals and indeed the thermoplastics. The elastomer seals, they are tested for decompression and also the age testing, whereas the thermoplastics are basically only subjected to the aging testing, not any decompression. This is due to the density of the material itself. If we talk about the ISO 23936, and this basically comes about because they've actually adopted the NORSOK M710 standard. And as you can see here on the 2009, they did the original draft, and that really covered the need for thermoplastic materials. Since then, in 2011, they've went to part 2, and now this includes the specification on the elastomer type products. When we talk about the NACE materials, a lot of people normally associate NACE as being towards the metal type parts. So within our product range, that would have an influence on things like the Wills rings, the metal O-rings, also the VariSeal when we talk about the spring energized seal. But there is specifications, as you can see here, which cover the elastomers, and these would be for things like explosive decompression or indeed working in high level H2S sour gas situations. When we talk about test conditions, of course, there's a combination of a certain pressure rating, temperature range, and the media cocktail. This is very, very critical because you try to optimize the performance of the material in the application. These are just some typical, the composition of the media, the CO2, H2S, the sour gas, and of course the CO4, the methane. So you have certain percentages of this which we put together, and this would be used in a typical test situation for either the API or indeed the NORSOK testing. For TSS, it's very important that we have as large a material profile as possible to these approvals. And as I say, I tie together again here the API 6A and the ISO standard number, the 10423. And for us, it's very important. Of course, we have some seals which are predominantly only an elastomer, but in some cases we do have combinations where you're bringing together the PEEK, the PTFE, and the elastomer part. Typical example would be like a V-stack seal. And then, of course, when we come to the NORSOK, once again, some slight differences in the materials that we have approved. But again, it's very interesting and very, very important that we do have such a wide range of materials based on the various applications that we get involved in throughout the oil and gas industry, whether it's a valve, whether it's a subsea connector or a downhole tool. These are some examples of the sealing profiles that we're using. Along the top row here, you can see that we're talking about essentially O-ring energized seals. First one being the glide ring. It's a double acting seal. We can produce this as a piston or indeed rod version. Same thing can be said of the step seal. The difference here is it's a single acting seal, but again we can make it as a rod or piston type seal. Then we come to the rotor glide ring, mainly for things like rotary union operations, so slow speed but high pressures. And then finally here to the excluder. This excluder we've used many times in subsea applications. Standard wiper seals would not be able to handle the external pressures. This one here we've had working 300-400 bar. And then finally over here, a captive glide ring. This would require a two-piece groove, but it does allow you to go over a port under full system pressure without the seal popping out. We have the capability to make flexi-mold. This is for O-rings when we talk in exceeding 20 inches in diameter. So really any size you want. Totally homogeneous, so it means that unlike some other O-rings where you'd use adhesive for standard vulcanizing, that could still be the weak link. This process means that you have the absolutely 100% against the media. The V-stack I mentioned earlier on, made up of different elements, different materials. The beige ones here being PEEK, the green is a TFM. We have the blue and black, which are Turcon PTFE compounds. And then finally we come here to the T-seal, again a double acting seal that we can use as a piston or rod. Up here we have a range of vari-seals. This is probably the most commonly used product we have in oil and gas. Reason being it has a really wide temperature range from cryogenic to plus 260. And also when we talk about the media resistance is excellent. The only thing you have to consider is to change the spring from the standard stainless to an alloy spring if you have to work in sour gas service. We have a range of non-metallic bearings. We can offer these in PTFE based materials. We also have in PEEK, and we have a terling cloth with resins which we call Orcot. The V-stack, again, it figures, and what we can have here is we can actually have the primary element which can be energized by the spring, so you have a seal which is live loaded. PEEK components is something we're getting more and more into in the last few years. We do use it in conjunction with some of the seals as an anti-extrusion device, but it can be a standalone item, either as a bearing or some other component. We have metal rings, again, excellent in terms of operational from cryogenic up to 850 Celsius. So really a wide temperature appeal, but for static service only. And then finally we come to a very high speed rotary shaft seal. What we have here is instead of having an elastomer contact seal, we have a PTFE contact. This means that the speed's typically up to 90 meters per second. That's the presentation. Do you have any questions? Thank you.